Good afternoon, everyone. Today we're going to discuss three very popular and powerful algorithms as far as machine learning is concerned. We said before that machine learning algorithms can be used for several purposes. One of them is what we call the CART, C-A-R-T. CART stands for classification and regression trees. Okay, so if you have data where you want to classify, let's say your variable of interest is, it can be binary, for example, whether a person will suffer from stroke or not. Okay, so you use the data that's given. It can be the blood pressure, can be some data about the heart, weight, age, gender, etc. We can use this in quote unquote independent variables, which is called features in machine learning. So you don't call it independent variables, but rather features. We can use these features in order to predict the variable of interest, which is whether the person will suffer from stroke or not. Okay, so that's one use as far as classification is concerned. And there are several ways you can do this. Okay, you can use decision trees. You can use random forest. You can use support vector machines, or even artificial neural networks. For your case, you're required to use decision tree, random forest, and SVM or ANN. So it's up to you. And as I said, I'll give bonus if you use the four methods. Okay, so what is random forest? Let's start first by going through the definitions of each. We're not going to really go into the nitty-gritty details of each of the algorithm for lack of time, but you can, of course, there are so many information available there in the internet. Okay, so random forest first. Random forest is akin to the decision tree that we did before a few weeks ago. Okay, I'm sorry, I forgot to mention that. So you have classification and regression trees. Regression is when your variable of interest, what you're predicting, is a continuous variable. When you say continuous, it's a numerical variable. For example, you would want to predict, let's say, the grade of a student based on his GPA, his gender, his age, his family background, etc. His grade in English, math, science, etc. So the variable of interest is the GPA, the grade point average. So that quantity is a continuous variable. It's a numeric variable, as against the classification models where the dependent variable is a categorical variable. So that's your CART, classification and regression trees. Okay, so we said that there are many algorithms that can be used, and the most popular ones are this one, decision tree, and then random forest, which is just an amplification of the decision tree models. And then you have SVM, support vector machines, and we have artificial neural networks, you have XGBoost, and several other models that are algorithms that are available. So let's start first with random forest, which is a versatile and powerful supervised. We learned this supervised machine learning algorithm. Supervised is when the variables or the features are defined. Okay, supervised machine learning algorithm for both this one that I was saying a while ago, classification and regression tasks. So how does it operate? It's just like decision trees in steroids, okay, which means you create several decision trees. What we did last time was using the party package, we learned how to create a one decision tree. For random forest, you have several, even hundreds of decision trees. Okay. So same thing, as I said, it operates by constructing a multitude of decision trees using the training data. Okay. And then you have the prediction for the individual trees. How is it used? Okay, number one, for random forest, you first do random sampling with replacement. Now, this is a very important phase of random forest. Okay, bootstrapping. Okay. Class, sandali lang ah. Let me just get water. Okay, so random sampling with replacement. What happens here is that you perform bootstrapping. Bootstrapping means generating several samples, hundreds of samples, and then doing the model based on those samples. So that's what bootstrapping simply means. So you're able to generate many decision trees because of the sampling. Okay, so for example, you get some samples first, and then you generate a decision tree, and then shuffle again, get other samples, and then you generate decision trees. You remember last time when we did our decision tree, we actually split it into two samples. One is a training data set, and the other one is a testing data set. For random forest, you create several samples, several data sets, and then you generate uh, decision trees out of that. Okay, so just an important note about bootstrapping. As I said a while ago, this is a resampling technique. Okay, to estimate the sampling distribution of a statistic. Let's say you want to get the mean, standard deviation. So you do that by repeatedly resampling with replacement. When you say with replacement, it's like the illustration that I gave up last time is that you have a container, you have let's say, or you can use cards, a deck of cards, then you get a uh, cards, and then you can put back the cards so that there's a chance for the cards that you drew a while ago to be repeatedly drawn. So that's what we mean by sampling with replacement. So particularly useful when the distribution of the data is unknown, okay, or when the sample size is small. Okay, so I will not anymore look at this nitty-gritty details of bootstrapping. It just says that it's a sampling with replacement. And then after you have several samples, okay, after you create multiple bootstrap samples, typically thousands. So that's why this in random forest you have several decision trees. It's because of the bootstrapping process. Okay, the statistic of interest, whether it's the mean, the median, etc., is computed for each bootstrap sample. So if you have thousands of bootstrap samples, then you'll have thousands of mean, standard deviation, etc. Okay, and then with that, you're able to calculate the sampling distribution, okay, or the bootstrap distribution. And from there, okay, you have your random feature selection, okay, and then you have your decision tree building, and then you're able to do the classification. Okay, so that's just the methodology inherent in random forest. And that's why you're able to create or generate several decision trees because of this process called bootstrapping. So there are advantages of doing the random forest. One is it's very robust to overfitting. We know that one problem with modeling is overfitting. When you use all your sample data in order to create your model. And we said that in machine learning, that's not done because if you use all your data sets, then you will not be able to create a robust model. When you say you're not able to create a robust model, when a new data comes and when you try to project or predict the new data, then you might not have a very good prediction. Okay, so a random forest, because it uses several samples through bootstrapping, it becomes robust to overfitting. Okay, and it's able to handle large data sets, and it provides a measure of feature importance. Okay, overall, random forest is a popular choice for many machine learning tasks because of its robustness, flexibility, and very easy to use. Okay, so you notice, class, I'm going over this quickly because anyway, you have the notes there. And also, at your disposal, class, are so many discussions about this in the internet. Okay, so the next one is support vector machines. This is quite different. So it's mostly used for classification. However, it can also be used for regression. So this is good. SVM is a very powerful tool, especially if the number of independent variables or features is very many, okay? And exceeds the number of samples. So very good tong SVM kung ganun yung, if that's the nature of our data. We have several features or variables, and then you only have a limited number of samples. So how does this work? It generates what we call a hyperplane. Okay, so I will not double into this this much, class. Suffice it to say that if you have the data points, what SVM does is to segregate or to split the data by use of a plane, a hyperplane. Now the hyperplane can be a line. Okay, so if you have only 2 dimensions, then the hyperplane will simply be a line. It will create a line that will separate the levels of classifications that you're interested in. Okay. Okay, then it can be 3-dimensional. So medyo mas mahirap nang i-visualize pag 3-dimensional class kasi you're talking about planes, no? And it can be higher dimensions, which we call hyperplanes. So you split your data, you're trying to split your data by creating planes. Yung human mind class, ang makakapture lang natin yung medyo yung ano yung 3-dimensional. So ang split ng mga data will be planes. But even then medyo mahirap na ma-conceptualize. Ang medyo mas kaya nating makita yung ano lang, yung line lang. Okay? 2-dimensional lang yung tinitingnan natin, and then line lang. Okay? So, ang importante naman dito, class, the way this model works is that it determines the optimal hyperplane. And it's the one, so kunyari may line tayo, class, no? Okay, let me just illustrate that. Okay, let's suppose we have this data. So si SVM class, magde-define siya ng ng hyperplane. Kasi ito 2-dimensional lang, magde-define siya ng line kunyari dito, no? Okay, so this is our hyperplane, which is actually a line. So yung mga distances, okay, yan mga distances yan, no? Distances from your observations to the line, okay, dapat maximum yan. If you add all the distances, dapat maximum yan. So that's why this tells us that it maximizes the margin, which is the distance between the hyperplane and the nearest data point from each class. Okay? Kaya ang tawag sa kanya ngayong class, support vectors. That's why it's called support vector machine. Okay. So, just like yung sa random forest, okay, hindi na natin masyadong i-discuss to, no, yung mga, what's important for us now is that makapag-generate tayo ng model using this. So, our treatment of this topic will not be that deep, no? Ang importante lang, medyo magkaroon tayo ng appreciation ng differences ng yung decision tree nakuha na natin. Tapos yung random forest, tapos yung itong SVM at saka yung ANN. Okay? In case hindi ko class matapos yung ANN, pwede natin matapos yung random forest, definitely matatapos natin. Yung SVM pwede, no? Baka yung ANN hindi natin hopefully masimulan natin, no? All right. So ang may advantages class si si SVM, si support vector machines. Ano yung mga advantages niya? Okay? This is effective in high dimensional spaces. So ibig sabihin pwede siya makapag gumawa ng iba't ibang hyperplanes, no? It's very versatile, okay? Can be adapted for various tasks including classification, regression, and it can even be used for outlier detection. Okay, tapos may regularization parameters. So ito mga special functions dito sa SVM na hindi na natin titingnan, no? So ang objective natin dito is for us to have just at least a good introduction to what these algorithms can do. Okay, and then last class yung artificial neural network, ANN. Okay, ito naman class parang minimimic niya how a brain works. Neural, kasi pag sinabi neural, it has something to do with the neurons in the brain. So what we do, kasi ang neuron sa brain class, it consists of mga nodes yan, tapos mga nagko-connect sila. No? Okay, sorry for this very crude drawing. Okay, so ito isang neural network, quote unquote, a very basic network which connects the nodes, no? So ganun din class yung ANN. Okay, so you generate what we call nodes called artificial neurons or perceptrons. Okay, so again, it's also used for classification, regression, etc. Okay, so for the details class, ito lang importante dito na malaman natin, ano? Merong layers dito, meron tayong input layer. Ito yung mga inputs sa ano natin sa minomodel natin. Tapos meron tayong output. So you have input, output, and then you have the hidden layers. Yung hidden layers, ito yung neurons na i-develop. And it's like a black box. So we don't know what's happening inside. No? Pag ANN, hindi natin alam kung paano gene-generate to ng randomly gene-generate ng model to. So, okay? All right. So let me skip this now. So may advantages din tong ANN. Okay, so now you can, I also place these notes here. How do you compare between the RF, the SVM, and the ANN? Okay, so there are different ways to compare them. Number one, accuracy. Ano yung accuracy? Ilan yung tamang prediction ng models? So i-compare natin yung accuracy nila, which you can also do via the confusion matrix. And then there are some other metrics, okay, which we can use in order to compare the different algorithms. Okay, so in this example, siguro titingnan natin 2 or 3 different ways to compare. Kaso hindi pa natin kagad magagawa yon. So yung summary na yun ng comparison, I'll just most probably share in another short video kasi definitely hindi natin matatapos to, no? Okay, so siyempre medyo I would rather that we understand kung ano yung ginagawa natin, no? All right, there are some packages that are very relevant to us. So in the interest of time, okay. So random forest, E1071, NNet, neural net, Caret. There are some other packages in machine learning in R that are also appropriate for this one, but let's just limit ourselves to this one first. And I leave you class to look at the description about these packages. All right, so please kindly chat if you're able to follow, kahit mabilis yung discussion ko, kasi ang focus natin talaga yung yung modeling mismo. Okay, thank you. So, waiting for the others. Good. All right. As an example class, we're just going to use a very basic data. Okay? Gagamitin natin yung iris na dataset. This comes prepackaged with R. So let's load this. I-load natin si iris. I'm not sure if I have discussed this dataset with you, but this is a very popular dataset. Isa to sa isang pinakagastadong no? Dataset that comes prepackaged with R. So sige, i-load natin to class. No? Data iris. Tapos i-view na rin natin. View. And then, kunin na rin natin yung structure. Okay. So what do we have here? Yung iris dataset consists of this one class. Okay, sandali I think I need to delete first everything. Okay. Delete na lang. Okay, so our data iris consists of 150 observations and 5 columns. So you have parts ng flower to, no? You have sepal length, sepal width, petal length, petal width, and you have the specification. So what we're going to do here is to create a model where we, based on these features, yung sepal length, sepal width, petal length, petal width, we will predict whether the species of the flower is setosa. Okay, tingnan natin kung ano yung ano. Okay. So, based on the structure class, numerical, 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 ang species natin factor with 3 levels, setosa, versicolor, and virginica. So, kunin nga natin table ng ano, just for us to table iris dollar species. Okay. Okay, so tagsi-50 sila, no? We have an equal distribution of setosa, versicolor, and virginica. So what's the objective here? We would want, so this is your case 2 class, no? Kasi yung case 2, you're going to use, although I'm not going to discuss decision 3, no? Kasi na-discuss natin yun. Here we're going to discuss random forest, support vector machine, at saka yung ANN. Okay. So let's first, yung ano kasi natin class, yung, okay, balikan ko tong structure. Okay, although factor na, no? Sa inyo ba class yung species factor na? Kasi sometimes hindi siya factor eh. Can you kindly check class if the species variable is a factor? Okay, thank you. How about the others? Okay, good. So kung factor na siya class, hindi na natin kailangan i-convert, no? But just in case it's not yet a factor, you'll need to convert it into a factor. Okay, so you know the code for that. So, okay, split ko na lang to. All right, any questions so far, class? Clear ba so far? Okay, I hope it's clear. So ang variable of interest natin dito, yung yung species. Ang gagawin natin, we will use machine learning in order to predict yung species natin, yung setosa, versicolor, and virginica, based on the features sepal length, sepal width, petal length, petal width. Okay? All right. So first is we're going to create 2 data sets, the training data set and the testing data set. So let's create set that seed para pare-pareho tayong data. Okay, and then I'm creating this object indices. And if you recall yung sample data, sample na function natin, okay, ilang observations to? Ilang observations yung sample natin, yung n natin is 1 up to the n row of iris, which is 150. Okay? Tapos, okay, dalawa lang training and testing lang. So, I don't need to define, kasi kung i-split natin into 3, dapat dalawa yung na-mention natin na parameter, no? Na numbers. Since dalawa lang yung pag-split natin, so I'm going to define one as 70% of n row. Okay, medyo iba dun. Dun dati probability yung ginamit natin, di ba? Prob is equal to C and then 0.7, 0.3. Pwede yon, no? Ito pwede din to. Ito, this will be more exact. Dun sa probability na ginamit natin dati, if you recall, prob is equal to C and then 0.7, 0.3. Yun, medyo estimate yon. Ito, exacto. And 70% of so ang end row ni Iris is end row niya is 150, di ba? 150 observations si Iris. Eh. If you multiply that by 70%, so this means that 105 will go to the first data set, and yung balance will be yung yung dun sa training data, testing data set natin. So we're creating this object called indices, and then we're going to sample out of the 150 observations, 70% of that. Okay, so i-run ko to. And if you check your indices class, print natin si indices. Indices. Okay, so you'll have here a true enough class, 105 observations. So what happened here? Okay, so lahat ng observations na to, number 28, 34, 59. Okay, so what you see here is that randomized siya, no? Random yung pagpili, no? So meron kang nandun sa row 138, 107, 111. So this is really randomized yung pagpili dun sa mga observation, which is good class kasi yung data natin, if you check, it's arranged parang alphabetically, no? Setosa, tapos versicolor, tapos virginica. So hindi maganda kung sasabihin natin 1 up to 105 will be for our training data set. Okay? So that's not good kasi ang mangyayari niyan kung 1 up to 105 will be our training data set, yan 105. It will mean that lahat ng setosa pupunta dun sa training data set natin. Lahat ng versicolor pupunta dun sa training data set natin. And a few of the virginica will go to our training data set. So what will remain, class, from 106, lahat to virginica na to eh. So ibig sabihin yung testing data set natin, lahat virginica, which is not good kung ganun yung pag-split ng data. Itong sample class, talagang randomize siya. No? Ayan. Okay, any questions so far, class? Clear ba yung pag-split natin ng data?
Yes, sir.
Okay. All right. So we have now the indices na object, di ba? Consisting of 105. All right? So ang gawin natin, yung train data will be yung iris ang data set natin, tapos yung indices natin. Lahat ng rows, di ba yung indices natin ito? Yan, lahat ng mga numbers na to will form part of your training data set. Okay? Saan na siya? Okay. And then our testing data set class will be, if you take a look at this, what I did was iris pa rin, pero negative indices. Ibig sabihin, lahat ng mga nasa indices, wag isasama. Okay? So only the rows that are not in the indices should be part of your testing data set. Okay, so I'll let you code that. So ilang class yung testing data set natin? Class ilan? Okay. Yeah, thank you, Eliza. You're correct. It's 45 kasi 105 yung sa training, di ba? So lahat ng hindi pumunta dun sa training, pupunta sa testing data set natin, comprised of 45 observations. Okay, sige. May I ask class if you're able to follow? Kindly chat, please. Yes or no naman please kung you're able to get it. Yeah, please interrupt me class kung medyo mabilis ako ha. And as I said, I'm sorry to be going through this a bit quicker. Kasi medyo may constraint tayo sa oras, no? Okay, good. Thank you for your feedback. Okay, next, ano gagawin natin? Okay, punta na tayo sa random forest natin, no? So first, let's create this. Okay, para mag-save tayo ng oras. Let me copy this. Medyo mahaba kasi. All right, and then let's take a look at them one by one. All right, so punta na tayo class sa random forest, no? Okay, and we're going to create this model first, RF model, random forest model. So we will be using the train data set. Ito, no? Okay, di ba may train data set na tayo? Ito. Yung train data natin comes from the iris data set, yung 150 observations, tapos kinuha dun yung 105. O kaya dito, data is equal to train data. Since may data na tayo na train, we can use that now. I don't think I have run this. Run ko na muna to. Okay, so then I should have now my train data set. Okay, and my test data set. If I print this, yan, tinan nyo class, no? Take a look at this, yan. Observation 28, 34, 59, 27, 101. Ito yung sa ano, no? Ito yung sa nasa index natin. And you can see that it's jumbled because jumbled yung iba't ibang flowers. No? All right. So, interestingly, tingnan natin class yung ano. Tingnan natin kung how balanced this is. Tingnan natin table, yung train data, species. Tingnan natin kung ano yung distribution niya. Medyo malapit, di ba? 35, 34, 36. Okay, may laman lang ng isa si Virginica over the ano. Kasi kung 105 yan, so kung equal distribution, 35, 35, 35. Pero ito okay lang kasi randomly na split siya, no? And then na-maintain pa rin niya yung ano yung proportion ng mga flowers. Not exact but almost exact, no? Okay, you follow this class? Naintindihan yung sinabi ko? Kasi kanina, di ba, 50-50-50 sila. So magiging hindi maganda kung yung nag-generate tayo ng sample, tapos sabihin natin, si Tosa 40, si Versicolor 20, tapos si Virginica 60, 45. So hindi maganda yon kasi na bago na yung ano yung distribution ng mga flowers, no? Alright, clear yung class? Paki-chat nga please kung kung naintindihan yung pino-point out ko na kung naging maganda ba yung pag-ano natin ng training and testing. Okay, good. Thank you. Okay, thank you for your feedback. Sino pa, class? Iba pa? Okay. Alright, good. Thank you so much for the feedback. Okay, punta na tayo dito, class, no? So, we're now going to create a model, RF model, no? We're going to use the function random forest. Of course, this is from the random forest package. And dito, class, ire-regress natin si species, okay, associated with all. Okay, yung dot na to, it means all. I don't know who among you were my students in FINLYTS or FinArts or you haven't taken it. Pero ito, class, ginagamit to sa modeling, no? So, species associated with, we could have, okay, dali ha. Pwedeng isulat na ganito, names, train, data. Ano yung mga laman yan? Ito, di ba? Ito. Ito yung mga variables natin. Just to point out, another way you can write this is, just for purposes of discussion, Control C. Ito ko na ilalagay, Control V. So species, instead of writing that, susulat natin to. Control C. Control V. So ganito yun, no? Especially for those of you who were not my students in FinArts, regression, baka hindi nyo alam to, no? Plus. Ayan, ganyan yung class, no? So ito yung ito yung actually complete na formula. Species modeled on are associated with the sepal length plus sepal width plus petal length plus petal width. Now since we're using all the features of the data, ito yung shortcut. Tilde dot. No? So this simply means all of the features. Ilan ba yung features ng data natin? Diba? Ang features ng data natin, except for the species, no? Kasi yung species yung minamodel natin. Ito. Okay, I hope that's clear, class. Now, to run the model, class, ito na tayo, no? So I'm going to run this RF model. I-run natin. Okay, so makikita natin dito, class. Ito yung RF model natin. So it's a list of 19. Yan. So marami siyang laman, ano? At marami siyang laman. Okay, andyan yung predicted value. Okay, andito yung error rate, confusion, etc. So this random forest object contains so many information. Okay? Ang daming information ng we can of course we can go deeper into this. But for now, what's important is nakapag-create tayo ng model for for species. Okay. So i-predict natin, class. Ang model natin RF model, and we're going to use the predict function. So I'm going to create this object, random forest train predict, and we're going to predict, okay? Ano i-predict natin? Using the RF model, ito, i-predict natin si train data. Okay? So take a look at how this is being done. Parang pareho lang itong ng decision tree natin. No? Meron tayong model based on the random forest. Tapos nag-create tayo dito ng prediction, okay, based on the RF model. Tapos gamitin natin yung train data and then i-print natin. Let's see what happens here. Okay, so you have RF train, ito, no? Predict. So ito yung mga prediction niya, no? So print natin RF train predict. Ito, class, no? So this is now the prediction of our model. Okay, so predict na si number 28 as setosa. Tinan nga natin dito, class, si Setosa, number 28. So, original data natin, number 28. Number 28. Actually, Setosa siya. Tapos, it was predicted as Setosa. So, for this, 34, Setosa din to, na-predict na as Setosa din. Okay? So, ito yung mga prediction based on the random forest model. Again, ano ginagawa sa random forest, class? Yung data natin na trained data, 105 yan, ang ginawa ni Arjan, nag-generate siya ng napakaraming sample. Okay? Napakaraming sample, and all of the samples, thousands yan, hindi lang natin nakikita, no? Behind the scenes, no? And then those samples, it generated several trees. Okay, nag-several trees siya doon, tapos kinuha niya yung kinulate niya yung for the final model. Okay, so that answers this one, class. So meron na tayong predicted value. Now, i-compare natin si predicted dun sa actual data set natin. Okay, so magkakreate tayo ngayon ng confusion matrix, this one. Random forest confusion matrix. Let's create a table. Ang nasa x-axis natin, predicted value is equal to itong predict natin, RF train predict. And then the actual value, nasa y-axis natin, nasa x at saka y, no? Or hindi, y at saka x, sorry. Ito yung y-axis, ito yung x-axis. Okay. So, i-compare natin dun sa train data natin. Pero yung train data natin, class, yung train data natin, ang i-compare lang natin dun yung species na object. Kasi ito class, mga species lahat to, di ba? Right? So, dapat i-compare natin sa species ng train data set. Okay, sige. So, okay. So, ito, confusion matrix natin, tapos i-print natin. Okay, may title lang tayo nagay. Random forest on training data. Control enter. All right. So this is the title, print confusion matrix for random forest on training data. And then we have here. Okay, wow, grabe. So na-capture ni random forest lahat, no? Okay, di ba? 100% yung prediction niya. Grabe. Okay. So medyo kinaya ni random forest yung kasi maliit lang naman yung data, no? 105. So you can see how powerful it is if yung bootstrapping niya. Kasi nag-create siya ng maraming decision trees. Okay. All right. Did you get this, class? Pause muna ako and ask you if you're able to follow along. So there should be no problem, class, with the random forest. It's actually easy. Yung function lang naman na random forest. So careful lang dun sa pagko-code, no? Clear so far, class? Any questions? Okay, good. Thank you. Thank you so much for your feedback. All right. So kita natin dito, class, no? Ang actual na Setosa 35. Ang predict niya 35. So perfect dito, no? Ganun din sa versicolor. 35, 34, 36. So it was able to 100% correctly predict yung training data. But of course, the test is in the testing data kasi hindi pa niya nakikita yung testing data. So let's do the same for the testing data. Okay, again, i-copy ko to. So see, yes, Eliza.
Hi, sir. Ask lang po, yung values natin, parang ever since kanina, pati sa RF model until yung confusion matrix, different po yung values natin. So
Magkaiba?
yes po, sir. Yung predicted na sa TOSA ko is 36. Then versicolor is 32. Then virginica is 37.
Okay. Nag-set.seed ba kayo?
Yes po. Same po lahat. Like everything.
Okay, sige. Ulitin ko to ha. Baka hindi ko na set.seed to ha. Okay. Yeah, I think hindi ko na set.seed. Okay. So, yung table ko. Ayan. Yung ganyan na ba yung sa inyo? 36, 32, 37? Pero kanina sabi nyo pareho lang tayo. Class, this is very important yung set.seed. Kanina yata hindi ko siya na run, no? I'm running this again. Hanggang table. Okay, so it's 32, 36, 32, 37. How about in your case, class? 36, 32, 37 ba? If you include set.seed, 1, 2, 3 yung ano natin. Hello, class? Feedback,
Yes, sir.
please.
Same lang.
Okay, so sorry a while ago, class, hindi ko yata na hindi ko na run yung set.seed. So you see the importance of set.seed para pareho tayo ng data. Okay, so if I check yung train data set natin, okay, so it should be 1450. Paki-check nga class kung pareho tayo. If the set.seed is 1, 1, 2, 3. Did you get 1450, 118, 43, 150? Ito na ba yung randomized na natin, sample?
Same na, sir.
Okay, good. Thank you. Yeah, I'm sorry if so mababago siguro dito yung natin. Okay. So let me run this again. Okay, run ko tong RF model natin kasi nabago na yung train data set ko. Okay, let me predict. And then let me now run this. So siguro medyo na tayo. Control Enter. Alright. Perfect ba yung sa inyo? Perfect pa rin prediction? Na perfect nang i-predict eh. Class, in your case, na correctly predict niya lahat? Okay. Yeah, do not expect class dun sa sa output nyo na malaki, na perfect lahat kasi ito maliit lang data set natin. So 150 lang eh. So the model was really able to generate a good model out of it. Iba na kung thousands na yung data set natin. Okay, so nagkataon lang to class and I was just pressed for time kung anong data ang gagamitin. Alright? So next class is ang importante yung sa testing data, no? Kasi ang objective natin, gusto natin makita kung yung model ba natin na generate, will it work if you use it on a data that has not yet been seen. Itong test data natin hindi pa nagamit, no? Hindi pa nakita ng model. So here I'm creating this iprepredict ko ngayon, iprepredict ko ngayon using the RF model si test data. So I'm generating here RF test predict. Okay, so i-predict natin if we're going to use the test data. And then same thing, i-print natin confusion matrix. So yung confusion matrix natin is may isang error lang dito, no? May isang error. So actually versicolor 'yon, pero predict niya as virginica. Yan, actual. Versicolor actually, pero predict niya as virginica. So one error, no? Not bad, no? Kasi nga maliit din yung data natin, as I was saying. So if we compute for the accuracy, no? I'm just generating this object C1, yung correct, no? Is the sum, ito yung ginawa natin dati, i-add natin yung diagonals ng ng confusion matrix natin, ito, random forest test confusion matrix divided by the sum of all the details of all the numbers sa RF test confusion matrix. So this will generate the accuracy. Yung kanina 100%, no? So ito 98, around 98%. Okay, so based on the data natin class, pinipredict lang naman natin yung type of color. This is quite a high prediction accuracy. Ito yung accuracy natin. Yung percentage, yung proportion ng tamang prediction divided by the total number of prediction. So 97%. Okay? So dun sa training data set natin, nakuha niya lahat. Okay, pero yung model na yun ginamit natin sa testing data set and it got 98%. Okay, now it's very important also to know that yung root mean square error, no? Kasi yun ang gagamitin nyo especially for the quantitative dun sa finals. So this is how you get the root mean square error. So RF, random forest, root mean square error, kinukuha nyo lang yung square root ng average ng, okay, bali ito class yung root mean square of the errors. So root siya class, root ito, square root, sorry. Root, tapos mean, average ng ano class. Kinukuha ko yung difference ng predicted value versus the actual value. And then, naka-square siya. Yun ang root mean square, RMSE, Ramsey kung tawagin. Okay, and then if I run this, sabi ko, print dito, i-paste mo yung random forest, RMSE, colon, and then put the value. Put the value of the RF, RMSE. Okay, hindi ko yata nabigay sa inyo to, no? Control C, bigay ko na in the interest of time. Yan. And what do you get, class? Ano answer? Ano answer, class? Okay, NA siya, no? Bakit? Kasi pag categorical class yung ano natin, yung dependent variable, hindi pa pwedeng mag root mean square error. Okay? So if I run this, you're correct, no? Not meaningful for factors. Okay, so you do not compute for Ramsey ng factors. So ano yung ano magiging basis natin? Unang-una accuracy, tapos may ibang parameters pa para ma-compare nyo yung mga models na ginamit nyo for your case. All right. So we have mga 20 minutes na lang. So simulan muna ko muna dito class siguro mag-ANN muna tayo. Okay? So after RF, yun ang RF class, no? So nakita natin class na around 97.8% yung accuracy ng random forest in predicting yung test data natin coming from the iris dataset. Okay, clear ba yung class? Clear? Paki-chat naman please kung clear yung random forest model natin. Okay, good. So again class, ito yung case 2 nyo, no? Yung finals yun, may iiba kasi yung variable of interest natin is a continuous variable. But generally the codes will be the same. And of course class, mas maganda mag-research din kayo, no? All right, so let's go here. Tingnan ko kung ito muna. Kasi medyo 242 control C. Ano to mapili to si yan, okay, good. So 242. Ewan ko kung kakayanin to. Control C. Ayaw. 242. Hanggang rule of thumb. 244, control C. Ay, nako. Masyadong maarte itong itong chat ng ng Zoom. Dapat pala sinama ko na itong notes na to sa Word kanina. Control C. Yan. Ano ko lang class paki-copy na lang sa nyo, sa RMD. Natin 246 hanggang 250. Okay, good. Tapos 251. Yan. Okay. Control C. All right. So I will not discuss so much anymore meron ng notes dun sa taas Ang gusto ko lang sana i-discuss dito yung yung hidden layers and neurons sa artificial neural network. Kasi sa ANN class, you will have to define kung ilang layers at saka ilang neurons per layer ang gusto nyo ilagay dun sa black box. Kasi sa ANN class, you ask R or the software to create a black box. Siya yung mag-create siya ng mga neurons, no? We don't know what's happening inside that box. That's the mysterious part about itong artificial neural network na to. Okay? But anyway, I think the best way to understand this is via an example. Ay, dito sa ko.
Okay. Apa itu terjadi pala? Oke, okay.
Palitan na ba ang
Sige, let's go.
Yasin, i-mute muna kita. Bakit may wait lang. Sumusulat sa ko sa may nakapatong dun sa ko. Sandali class Okay. So here, mag-create tayo ng train model. Now, there are several packages that can be used. For me, isa sa pinakamaganda to. Ito yung neural net, no? So, I'm creating this ANN. Sa training muna gagamitin natin, no? Train model. And the function is neural net. Then, again, si species, rene-regress natin dun sa 4 na features. And the data is equal to train data. Now, ito yung sinasabi ko, no? Hidden is equal to C, 5 and 3. Now, this means that dalawang layers yung natin, yung nodes natin, yung neurons natin. The first layer consists of 5 neurons. The second layer consists of 3 neurons. Okay? Now, how do you determine this? Ano lang to class? Trial and error muna, no? So, maybe you should usually isang lang. So, pwedeng hidden is equal to, let's say, 5 lang. So, isang lang yun, isang layer lang yun. But let's show this for a while, no? Pakita muna natin to. Okay, so we're creating this model, artificial neural network on the trained model. Ang function neural net, species regressed on all the parameters, all the features, data is equal to trained data, and then hidden. Maglagay tayo ng 5 layers. Ang first layer will have 5 neurons. The second layer will have 3 neurons. Okay, so run natin to, control enter. Okay. So ano laman itong na to? Okay, so it's still running. Medyo it takes a bit of time. Okay, habang nag-aano siya ng class, habang nag-run pa siya, let me copy. Okay, itong support vector machine. Okay, ano ko siya? Control C. I-set ko muna tong SVM Yan, kumasya. Okay, so I gave you the code for SVM. Okay, I'll do a recording of SVM kasi hindi natin na-discuss, no? Pati yung continuation ng A and N kasi mukhang hindi natin matatapos. No? Alright, nagra na sa inyo class? So may A and N train model na ako. It's a list also class. No? List siya. Ito yung mga laman niya. No? Okay. So may response, may covariate, may error, actual, okay, etc. No? Generalized weights. All right. And if I for example print this, medyo maraming laman yan kasi sabi nga natin list yan, di ba? So number 1 yung data. Okay? Tapos ito number 2. Ito. Ito importante ito, net.result. Okay? So ano ibig sabihin itong net.result? So ito yung first observation natin, di ba? Ito yung train data natin, si number 14 yan. No? Okay. So anong ibig sabihin niya yan? Ito. So ito, 1.0023, ito negative 3 times 10 to the negative 4. So this is practically negative 0.003. No? Tapos ito 0.0005111. Okay. So yung pinakamalaki, these are probabilities class. So yung pinakamalaki number dito, yun malamang, yun ang prediction niya for number 14. Okay? So ang pinipredict niya, si number 14 is, ano yung number 1 sa iris natin? Si setosa. No? Setosa, tapos versicolor virginica. So ang prediction niya, si number 14 is setosa. Si number 14 dito is setosa, correct. So dun sa number 1, sa number 14, correct yung prediction niya. Sa number 50 class, again, 1 to almost 1, small number, ang prediction niya ulit si setosa yan. So si 50 class, 1 to 50 is setosa, di ba? So tama na naman yung prediction niya. Number 50, setosa siya. Okay? So 118, this is virginica kasi 1 to 50, 51 to 100 is versicolor. And then 101 to 150 is virginica. So ito, so this is 0.027, this is 0.0003, mas maliit ito. Ito, almost 1, no? So ang prediction niya dito si virginica, which is correct. Okay, which is correct. So we can see here that the that result will tell us the probabilities ng result ng ano natin. Okay, and there are other things here. Okay, nakasama dito sa model natin. Now, one good thing about the neural net is that we can plot yung, okay, i-delete ko na muna to. We can plot the neural net, no? And see what happened there. Medyo mahirap din class intindihin. So, ang importante na lang yung prediction. But it's just weights, no? Nag-recreate lang siya ng mga weights. Haba nitong output. Yan. I-X ko na muna to. Here class, yung plot. Alright? Masyadong... Ay. Ito to, class. I-plot natin class yung ano, yung neural network natin. Yung neural network natin class, as I said, it will look like input muna, tapos yung layers, tapos yung output. So plot natin siya. Okay, ito yan class, there. So this is your artificial neural network. Yan. So mukha siyang ano class, ano? Mukhang yan, okay. So first is the inputs natin. Ano yung inputs natin? Yung 4 na features natin, sepal length, sepal width, petal length, petal width. And then you have here 2 hidden layers, no? Yung 2 hidden layers natin, ito yung hidden is equal to C, 5, and 3. No? The first one has 5 neurons. 1, 2, 3, 4, 5. The second one has 3 neurons. 1, 2, 3. And then ito yung output natin. Alright? Setosa, virginica, versicolor. Ito. Input, output, hidden. Ito class yung black box. Okay? We do not know how R is doing this. Ito yung tinatawag natin na, it's also called, it's usually called black box. No? So ito mga weights lang to. These are just weights. And each of the node here has a contribution to all the nodes here. Tignan nyo, no? Itong node na to, dito, may contribution. Itong node 1 na to from sepal length, sepal width, yung apat na yan, di ba? Apat, no? Tapos, nagge-generate ng another node dito. Okay, ganun din dito, class. All of these nodes here are connected to each of the three layered nodes here, three nodes here. Okay, so meron din dito. And finally, kinoconnect na siya dito. Okay, each of this, 1, 2, 3, may contribution dito. Okay, and then it predicts whether it will be, yung probabilities ng setosa, virginica, and versicolor is generated through the net result. Okay, so were you able to generate the plot, class? Okay, baguhin natin to. Kunyari, hidden is equal to 2 lang. 2. What will happen if hidden is equal to 2? Okay, so i-run ko to. Tapos, i-plot ko siya. Hindi pa tapos tong ano, tong 2. So, isang layer lang yung class, no? One layer with 2 nodes. Yan, tingnan nyo. Ha? There. You can see, no? Hidden natin, dalawa. I just put 2, which means isang layer lang yon, tapos 2 nodes. Alright, rule of thumb, class, dito, may pinakita ko dito ano, sa ito, rule of thumb. As a rule of thumb, you can start with the number of neurons between the number of input neurons and the number of output neurons. If you have, ito may parang rule of thumb lang. Kunyari, 4 yung input natin, tapos 3 ang output. Then you might start with the hidden layer of size 4 or 5 neurons. Okay, some a bit equal to the greater number or a bit more. So ito yung suggested lang na rule of thumb. So in our case, kasi, ang case natin, di ba, ilan yung inputs natin? 4, no? Tapos ang output natin, 3. So perhaps you can start with hidden is equal to 5. Pwede rin ganyan lang. So you can run this. Okay, and of course, mag-try pa kayo. Sa case nyo, class, try at least 3, mga 5, no? 5, siguro, depende sa ano kasi sa data, no? Siguro, pero do not go beyond 3 layers, no? Masyadong yung 3 layers. Sample lang, kunyari, paano yung 3 layers? Kunyari, 1, 1, 1. Ibig sabihin nito, class, 3 layers na tigi isang node sila. Okay, run ko to. 1, 1, 1. Okay na, tapos i-plot ko. Ayan, tingnan nyo, class. Ayan. Diba? 1, 3 hidden, 3 layers of 1 each. Okay? So, is this good? Siyempre, kukompute natin, class, kukompute natin yung, nito, yung accuracy, no? Okay? So, I just wanted to explain that. So, balik ako sa 5, 3, no? 5, 3. I-run ko ulit to. Medyo matagal ng konti kasi nga 5 layers yan. Ay, almost time na pala. 1 minute na lang. Okay. So, those who need to go, you may go now, class. No? At tapusin ko lang tong recording na to. At least hanggang dun sa hanggang dito sa pag-predict. No? Alright. I-share ko na to. Same thought din yung class, no? Pero dito, iba yung ginawa natin, iba yung gagawin natin dito ng konti. So I'm now creating this predict. So pine-predict ko yung ANN natin train. Di ba may model na tayo? No? May model na tayo. Tapos, wait. Ano ba ako? Ito pala. So predict ANN train. You use the function compute. No? Co-compute natin based on the ANN train model dun sa train data. Tapos, ano yung kino-compute dun, class? Yung 1, 2, 3, 4. Okay? Ang kasama yung 1, 2, 3, 4. Ano yung 1, 2, 3, 4? Ito yung ano, ito yung sepal length, sepal width, petal length, petal width. Yun ang gagamitin natin for the computation. So if I run this, so meron tayong prediction. No? Ito, class. It's a list of 2. So meron tayong yung mga neurons at saka yung net dot result. Okay? Which na-generate natin to kanina, di ba? Yung net dot result na to, yung probabilities. Okay, so this is another way to do it. Although nakita na natin to dito sa ano, di ba? Sa model natin dito. Nakita na natin yan, yung mga probabilities. Ang gawin na lang natin ngayon is ito yung class, no? Yung view kanina ginawa na natin. Tapos ito na lang yung predicted untrained natin, yung net result niyan. If I just print that, ito 'yan, no? So ito yung probability. So dito ang pinakamalaki is 1. So therefore, dito sa observation 14, ang prediction niya setosa to. Then setosa pa rin. So ito yung pinakamalaki dito, 0.99, si Virginica, etc. So andito lahat ng mga predictions based on probabilities. Okay? All right. Siguro class, kasi time na talaga, no? Did I share this with you? Shinare ko ba to? Na-share ko na to? Okay.
Yes, sir.
So ang gagawin ko na lang kasi time na, I'm sorry for the extension. I'll just discuss yung ANN ulit, no? At saka yung SVM. So yun na lang di-discuss ko. You may try this, ano? You may try this. Ito lang, i-run natin to. So nag-generate to ng pred.2. Okay? If you print that, yun. Linagay lang niya yung numbers, no? Numbers. Tapos, ngayon take note class, kung x1l, kasi minsan binabago niya to yung name ng variable, x1l, so kanina x3l yan So, I will have to change this. Lahat na nasa baba dito dapat x1l to. Kanina x3l siya. So, anong ginagawa nito, class? Kino-convert ko lang yung mga numbers na to. Ito. Kino-convert ko lang yung pred.2 pala. Itong 1 na to, kino-convert ko lang into this one. Setosa versicolor. If I run this, 1L to, sorry. 1L, 1L, 1L. Ang sinasabi lang dito, lahat ng 1 gawin kong setosa, lahat ng 2 gawin kong versicolor, lahat ng 3 gawin kong virginica. So if I run that, ayan. And if I print pred2, yan, naging ano na siya, no? Naging text na siya. Okay? And then, i-discuss ko na lang, class, dun sa sa continuation, yung paano pag yung confusion matrix. Okay. Actually, ito na lang, class, no? Uli na to So, i-run ko na lang to, ha, please. So, gagawin lang natin na factor yung pred2. And then, confusion matrix na, class. There. All right, so based on our confusion matrix, ng trained data set, 100 din siya. 100%. And what's good about yung caret package class, ito yun eh. Nagbibigay siya ng maraming information about our model. Sensitivity, specificity, etc. I'll just discuss this dun sa ano natin, sa additional na video. All right, so with that class, thank you so much. Maraming salamat for your patience. And yung mga wala pang data set, please see me later. Mag-chat kayo sa akin. Maybe around 7 o'clock in the evening kasi may mga class pa ako. No? Alright, sige. Thank you so much, class. And salamat sa term.